Cystic fibrosis is a genetic disease. People with cystic fibrosis have inherited two copies of the defective cystic fibrosis gene. For people that have cystic fibrosis, their cystic fibrosis transmembrane conductance regulator, the CFTR gene, causes the CFTR protein to become dysfunctional. When the protein is not working correctly, it's unable to help move chloride, which is a component of salt, to the cell surface. Without the chloride to attract water to the cell surface, the mucus and various organs become thick and sticky. Here is Yang, the CFTR protein plumber. He has no headphones and can hear the signal to let the ions through. Here is Yang plumbing and letting ions through the plasma membrane and out of the membrane. Now is the mutated CFTR protein plumber. He can't hear the signal to let the ions through because he as a protein is dysfunctional. Since he doesn't get the signal, he can't start plumbing and letting the ions through the membrane. Now let's zoom in and see what's happening under the membrane. First, a calcitonin gene-related peptide ligand, or CGPR for short, binds to the protein receptor just like a cap fitting into a pen. The binding of the ligand to the G protein coupled receptor activates the G protein attached to the receptor. The G protein activates adenylyl cyclase, converting ATP to CAMP. CAMP activates the protein kinase A to send the cellular signal to the CFTR protein. In the normal function of the protein, ions will be able to pass readily through when the signal pathway is performed correctly, as shown here with the Yang that has no headphones. When the protein does not function, the signal pathway is still performed correctly, but the ions are not able to pass through the membrane. The protein acts as if it is plugged and does not allow ions to flow through.